Here are your video notes for lesson 5.3, and it's about, you guessed it, triangles. Which you might think it's a triangle because it's got three sides, which is true, but then they should have called it a tri-side. They call it a triangle because it's got three angles. And the first fact that we want to prove to you about triangles is that if you take the three angles of a triangle, and I just happen to have torn that off that side, angle 1, and if I tear off angle 2 here, angle 2 I'm now going to set up there, and if I bring angle 1 in, you should see that the angles 1, 2, and 3 end up making a straight line when you put them together, so that those three angles added up to that 180 degree angle. And I have a second triangle just to prove to you that was not a special triangle, and I want to show you that if you still take and you tear off these three sides, or these three angles, and we place them together the same as what we did before, that these three angles as well will turn out to end up equaling a straight line, which is 180 degrees. So hopefully that proves to you that the three angles in a triangle will always add up to 180 degrees. Feel free to cut a triangle out at home and take the three angles and put them together to see that. For the rest of your video notes, you should be taking these on the notes template that was provided to you in class, or you can print another one off from the website. But what we just showed you was that the three angles in a triangle will always add up to 180 degrees, so we can get that written in. If you can't recognize the little degree sign, write another one. The examples that you see here are actually the examples that were in the book. When we should notice that you should, from past experience, know what an acute triangle is, and that's a triangle that has three acute angles. That would be, this triangle is an acute triangle because all three of these angles here are going to be less than 90. What a right triangle is, and that would be an example of where you have just one right angle, and that's what we have right here in this triangle because that is a right triangle. And you can also have an obtuse triangle, although we don't have one drawn here to show that, but that would contain one obtuse angle. For what we're doing here, finding angles, it says to find the x value in this acute triangle here, and in order to find out what x is right there, the size of that angle, we would say that x plus the 63 degree angle that's here plus the 42 degree angle that's there, if we add all three of those angles together, we now know they should add up to 180. So now if we add together our 63 and 42, they would come out to 105. And on this side we still have x plus that 105 to equal 180. So if we subtract off 105, subtract off 105, this will get rid of things because it equals 0. X will equal 180 minus 105 is 75. We now know that the x value that goes right there is 75 degrees. So our three angles add up to 180. If we drop down and look at the next triangle, our three angles are y, 37, and we have to remember how big the 90 degree or the right angle is, and that would be that it's a 90 degree angle. So we have y plus 37 plus the 90 degree angle has to equal 180. And if we add up the 90 and the 37, we will end up with y plus 127 equals 180. To find out what y is, we need to subtract 127 from here, subtract 127 from here, and we will get that y equals 53 degrees. Okay, moving on. This is another way to classify triangles by sides instead of by angles. Should know an equilateral triangle is one in which it has three congruent sides, and as a consequence of that, it'll also have three congruent angles. An isosceles triangle, which I usually remembered because you got two s's in the word there, has at least two congruent sides, and it'll have two congruent angles as well. In a scalene triangle, the third type classified by sides, has no congruent sides. So if we come down and look at the examples we have here in 2, for 2a, it says to find the measures of the angle in the equilateral triangle. That's because this side, and this side are all the same, so the angles end up having to all be the same, and they represented them with m. Well, if all the angles are the same, that means that the measure of angle m plus the measure of angle m plus the measure of angle m, all three have to add up to be 180. If you add up m plus m plus m, that'll add up to 3m. equals 180, and if we divide this by 3, we'll get m by itself, and we'll get that m ends up being a 60-degree angle. So now we know that each one of the m's, that's a 60-degree angle, that's a 60-degree angle, and this is a 60-degree angle. So the size of the missing angles was 60. If we drop down to example 2b, it says find the measure of the angles in the scalene triangle. It's scalene because none of the sides are the same length. The angles are labeled here 2p, 3p, and 4p. What do we know about 2p, 3p, and 4p? We know that if we add them together, they should add up to 180. And if you add them up, you should get 2p plus 3p is 5p, 5p plus 4p ends up being 9p. So 9p equals 180, which if we divide this by 9, we divide this by 9, we'll find out that p equals 20. Now we're really not done with this problem yet, because in order to find out the three missing angles, this angle, which is 3p, is going to have to become 3 times the value of p is 20, so that's a 60-degree angle there. The 4p angle will become 4 times 20, which is 80, so that's an 80-degree angle, and the 2p side will become 2 times 20 degrees, which is a 40-degree angle. So the three angles are 40 degrees, 80 degrees, and 60 degrees. There's a little extra work to do in that one. But if you check, the 60 plus the 40 still adds up to 100, and 100 plus 80 adds up to 180. So these three angles could be the three angles in a triangle. Alright, next, finding the area in a triangle that meets given conditions. This is going to require a little more thought. It says that here that the second angle in a triangle is twice as large as the first. Well, if we say that the first angle is equal to x, then the second angle is equal to what if it's twice as big? Hopefully you guys thought out that would be 2x. If we read on, it says that the third angle is half as large as the second. So our third angle would have to be half as large as the second. That would be a half times the second angle was 2x. 1/2 times 2x actually just equals x again. So if we use these three amounts as our angle sizes, I'm trying to get the red color. Hey, took me a while, but if we use x, 2x, and 3x as our three angle sizes, we would know that x plus 2x plus x again equals 180. And x plus 2x is 3x plus another x, that would give us 4x on this side is equal to 180. If we divide by 4 and divide by 4, we would find out that x equals 45 degrees. So if this angle is x, we know this one is 45 degrees. If this is x, we know that's 45 degrees. And our third angle, the angle right here, 2 times x, this angle right here would result in a 90-degree angle. So our drawing would conclude a 45-degree angle. Or I'm sorry, it would include a 90-degree angle to start with. And if these two angles are going to be the same, they have to be opposite sides that are the same length. And we would have a isosceles right triangle there as far as a result of what we had. And if you see, it says draw a possible figure for it. But this is now our 90-degree angle, and these are our two angles that are 45 are out here and here. Triangle inequality theorem. That actually, on your sheets, I believe you have a drawing of two triangles. I don't have them here. And on your sheet, the two triangles are, the first triangle is 4, 5, and 7. It's 4 this way, 5 this way, and it's 7 across here. Well, when you have a triangle, I don't know if you've ever heard it before in geometry, the shortest distance between 2 points, this point and this point, should be a straight line. Well, if 7 is the shortest distance, if you go from here to and then to there, then that shouldn't be as short as the 7. It should be longer. And if you look, the 4 plus the 5 is longer, and that has to do with what we're talking about. The other triangle showed a side being 7, showed this side being 4, and this side being 2. there's no way that's going to be long enough to get there, because this is going out of the way to walk from here. It's going out of the way to walk from here up to here and then down to there, compared to if you had just walked straight from here to here. So anyway, the triangle inequality theorem ends up saying that any, pen's not writing good, any two sides of a triangle must add up to more than the third side. So if you get that written down with us, and feel free to pause the video if I'm going too fast for you at all, or you can rewind. If we look at the next thing, it says tell whether the triangle can have the sides with the given lengths. Well, if we check out the 9 and the 4 and the 11, if we take two sides and go 9 plus 4, that should be bigger than 11. If we test it out, 9 plus 4 is 13, that's bigger than 11. So that's okay. But if we test out the 9 and the 11, 9 plus 11 should be greater than the third side now is the 4. That comes out to 20 is greater than 4. That's okay. We still haven't tested out the 4 and the 11 to make sure that if we do 4 plus 11, that comes out to be greater than the other side, which would have been 9. This is 15 is greater than 9. Well, that's okay. So can this make a triangle? Yes. And on the last one, as far as this example, B here, if we test out the 6 and the 3, 6 plus 3 should add up to more than 10. 6 plus 3 is 9. Is 9 greater than 10? Nope, that's not correct. So no, these could not make a triangle. We don't have to check any farther. That concludes your video notes for lesson 5.3.